is Nurul Iziani binti Ramli. So today I would like to present on the MC3 individual project on integrated IC design. So in this project, we needed to fully convert or implement RTI to GTS2 implementation. So using Synopsys tool. So in my case, I provided an 8-bit arithmetic logic unit ALU in System Verilog, written in System Verilog together with its test bench. And then I proceed with running simulation, synthesize it and run physical implementation and static time analysis. So the goal of this project is to optimize the design for PPA, while also ensuring successful timing closure and verification. So on the simulation and verification, I was using VCS tool, and for synthesis I'm using design compiler tool, and for layout and physical implementation I'm using ICC2 tool. And for the lastly, after everything is done, we using prime time for running static time analysis. So on the left side here is the ALU.sv, which is the design of the the design that we are going to fit into each of the process. So it's just a simple design with one big operations, A and B as input, and Y is the outputs of the operations. And as you can see, it will select the operation based on the input OP and give out the result to Y. So in this case, the Y is 9 bits compared to the input of 8 bits to ensure that for this plus operation, the carry out will also be taken into the output. So this is the test bench that I have designed for this ALU. So basically it will just run each of these test case with expected results on the so this is the operation bits, input A, input B, and the expected result that I will compare to from the hardware. So I have run this test on one of the virtual machine provided, and this is the result of the timing diagram. As you can see, let me zoom in a bit. So it works as expected, which is when the input is A and the input is A and B, and the operation is 0, which is plus, then we will get it at the enable positive edge enable here is F, so which is the correct value as we can see here. So 10 plus 5 is 15, so on and so forth. So I also provide did a display so for easy monitoring, so we can see that the output is as expected as what we want it to be. So in this verification, I consider as pass, so we can proceed with the synthesis process, placement, and also SDA. So for synthesis, I have actually provided the constraints based on the project requirement, and I just I automate the flow by using a ticker file, which I just run this ticker script, and it will run the whole thing for me. And this is the log mentioning that no error has been reported, and then I proceed with ICC2. So the results of from the synthesis report are like Okay, so we have like total cell area is 208, with the nets is 235, and most importantly is the setup slack is 1.25, which is met. And it's a positive slack, positive delay. Yeah, so this is the block diagram of the schematic block diagram of the input and the outputs of the LLU, and this is the LLU before the optimization by DC tool, and once I optimize it, it become like this. Yeah, and then for physical implementation is also the same. For ICC2 tool, I provided a ticker script as well, and it will run everything for me and and verify the layout versus schematic, the ZRT, and also report the timing and area and the design. So this is the log. As you can see, there are actually no error reported, so it runs successfully. It's quite long. So this is the final placement that I screenshot from the ICC tool. So you can see this is actually the LU, and the clock connection and all the voltage sources. So after physical implementation, you can see that the total area with nets is slightly increasing compared to before. So before, during synthesis, 235 units, and after physical implementation, it increased by a bit of points. Most importantly is the setup slack is still 1.20 nanosecond positive slack, which is slightly better than the previous synthesis reports. And then for static timing analysis, I also provided the constraint for the prime time tool to consider. This one is based on the requirement from the project. And I also created a ticker script to automatically run each of the process and report out the timing. And this is the log, and let me go to the report. Okay, so from the STA report, we managed to get a positive slack for both of the setup and hold timing. So a bit of comparison here. So for the PPA comparison, from pre-layout, post-layout, and post-layout STA, the timing is improving. And then area is a bit increasing. So there is a win and lose situation if you for the optimization part, which is done by the tool. So that's all for my presentation for the project. Thank you.